Good morning, and you're welcome to this morning's webinar. My name is Pat Murphy. I'm Head of Environment Knowledge Transfer with Teagasc. The Signpost webinar series is brought to you in collaboration with National Rural Network, Dairy Sustainability Ireland, and Food and Drink Ireland Skillnet. Just remember, you can send us your questions by clicking on the Q&A tab at the bottom of your screen. And today's presentation, along with a recording of the webinar, will be made available on the Teagasc website over the coming days. Today, we're joined by Dr. Donal O'Brien, Research Officer with Teagasc in Johnstown Castle. Donal's topic is carbon sequestration in Grassland. You're welcome, Donal.
Hi, Pat. Thanks for having me.
We're also joined by Pádraig Foley to help out with questions at the end of the presentation. Pádraig, you're welcome.
Thanks very much, Pat.
Okay, without much further ado, Donal, if you want to share your screen and we'll get the presentation underway. Thanks.
All right. So you can see it okay? All right, so during my talk this morning, I'll give I suppose just an introduction to the Green Deal and Climate Action Plan, the science and quantification of carbon sequestration in temperate grasslands, the impact of land use and land management on carbon sequestration, and cover a bit about climate neutral livestock farming. So the European Green Deal is a new growth strategy for Europe that aims to create new jobs, a cleaner environment, and a better quality of life. The first woman president of the European Commission, Ursula von der Leyen, wants Europe to become the first climate neutral continent in the world by 2050. And the expected benefits of this are less pollution, more affordable energy, and more sustainable food production. So it's largely built around the circular economy, so moving from a linear to a circular economy in a way that the economy gives more than it takes away. The European Union is investing €1 trillion in the Green Deal, and it expects this investment will give businesses the confidence to make long-term decisions on environmentally responsible projects. So the farm to fork strategy is at the heart of the European Green Deal. It will generate fair economic returns for all actors in the food chain, ensure food is available and nutritious and more sustainable. It wants to reconcile, I suppose, what consumers can eat with the requirements of the planet. So by reducing the environmental and carbon footprint of food production and consumption. So I guess the key part of this in the farm to fork strategy is the low carbon farming initiative. So this aims to promote practices that will remove carbon dioxide from the atmosphere, so to curb the impact of climate change. And for doing this, farmers and producers will be rewarded through the Common Agricultural Policy and through public and private initiatives or carbon markets. So in Ireland, the Climate Action Plan is largely consistent or aligns with the long-term goals of the Green Deal and the Farm to Fork strategy. The Irish Action Plan outlines the measures Ireland will take to meet its greenhouse gas emission commitments for the effort sharing regulation for the next period 2020 to 2030. It sets decarbonisation targets for each sector of the economy, and will require concerted action from all of these sectors. So the challenge for agriculture is to meet these, to meet its greenhouse gas emission targets, while ensuring it produces sustainable amounts of food for the population of Europe and elsewhere. So within that then, the government action plan expects the sector will deliver the total amount of carbon credits, or the carbon flexibility allocated to Ireland, which is 26.8 megatons of carbon dioxide. So to put that in context, this chart shows the total amount of greenhouse gas emissions emitted by are covered by the effort sharing regulation in Ireland. So about, on average, the sector emits 40 to 45 megatons of CO2 equivalent per annum. And the projections show that this will, it looks like this level of emissions will not really change over the period unless new strategies for reducing emissions or increasing carbon sequestration are introduced. So in 2018, Ireland exceeded its binding national emission limit by about 5 megatons of carbon dioxide equivalent. Agriculture and transport represents 75% approximately of the emissions covered under the effort sharing regulation. The EPA projects that Ireland will exceed its carbon budget over the 2020 to 2030 period of this regulation by 52 to 67 megatons of carbon dioxide equivalent, without the flexibilities of carbon sequestration and ETS credits. So when we include the flexibilities, the gap narrows. So instead of, the gap narrows to an overshoot of between 7 to 22 megatons of carbon dioxide equivalents over the period. And this assumes that the carbon sequestration will be fully delivered by the sector, that sequestration occurs in, so agriculture, forestry, and land use. So over the period, agriculture emissions are expected to grow gradually, and this is mainly due to an expected increase or maintenance of the size of the national herd. So, as you're probably well aware, the three main pillars of the Teagasc greenhouse gas mitigation strategy are firstly, to reduce agricultural greenhouse gas emissions by improving the efficiency and productivity of our production systems, and to displace fossil fuels with bioenergy and improve energy efficiency. And lastly, then, to enhance the sequestration of carbon in our soils, in our grasslands, and in our forestry. So I'll cover the carbon sequestration in temperate grassland. So before I get into carbon sequestration, I'll just cover the carbon cycle. So the first step of the cycle is the absorption of CO2 and also water from the atmosphere and the surroundings by plants, and the use of sunlight to produce organic carbon by photosynthesis. The carbon then that is assimilated or photosynthesized by the plants or vegetation, some of that carbon dioxide is respired or used up for energy and lost back to the atmosphere. Carbon is also then respired by the animals through respiration as well, when they consume or digest the feed. So you get carbon dioxide and you get methane loss as well. Then the vegetation that is not utilized by plants or by the animals is decomposed by microbes, and during that process, carbon dioxide is also released to the atmosphere. The decomposed carbon then that is left over moves into the soil pool, so it moves into the organic matter pool, and there's two pools within organic matter. So there's the active carbon pool in the topsoil, and then there's the passive carbon that's deeper down the profile, that is less available and less prone to carbon loss. So some of the active carbon in the labile pool can be lost to the atmosphere or dissolved as well. And then finally, there's the hydrocarbons. So they're usually found very deep underground, and are removed or extracted for the production of energy and petrochemicals. So when that occurs, carbon is released, and use of these carbons for energy production for the powering of machinery releases carbon dioxide as well, and some of the carbon then that is spread on the land by machinery using tankers is returned back to the soil. So that's an overview of the carbon cycle, and carbon sequestration is part of this cycle. So it's a natural biological process. So I suppose the main phases of the process are largely the steps that I showed you there at the beginning of the carbon cycle. So during the process, the carbon that is assimilated or photosynthesized by the plants is transferred into the soil and into wood and fixed in those substances. So the difference between the carbon that is photosynthesized and the carbon that is respired gives an indication as to the amount of carbon that is sequestered. So the gross carbon sequestration, roughly speaking, is the difference between photosynthesis and respiration. So the main factors that influence carbon sequestration are climate, the type of soil, land use, and land management. So in Ireland, our climate is humid and temperate, so that produces conditions that are favorable to the storage of carbon in our soil and the sequestration of carbon. In other regions or more arid zones where there's prolonged periods of drought, the uptake of carbon is usually by plants is usually less than the release of carbon back to the atmosphere. So the amounts of carbon stored in soil is usually lower, and as a result, sequestration, or not as a result, but the sequestration levels are lower, or you might get carbon loss levels are higher. The type of soil then has a major impact or bearing on the amount of carbon that is stored. So I suppose within mineral soil types, so heavier soils with more clay particles tend to store more carbon than sandier soils. They have more capacity to hold carbon within their aggregates than lighter, sandier soils. And then the peatier or heavier soil types or organic soils store very large amounts of carbon because I suppose they don't decompose the organic matter because they're saturated from large parts of the year, and as a result, carbon tends to build up in these soil types. In terms of land use, the categories of land that hold the most, or the category of land that holds the most carbon is forestry, followed by, or the category of land that holds the most carbon is actually the wetlands, followed by usually forestry, grassland, and arable land. So the reasons for, I suppose, the higher levels of carbon in grassland and forestry compared to tillage land is because the land is not exposed, or the land is under constant vegetation. So as a result, then the carbon is less exposed to the atmosphere, and there's less chance or risk of carbon being released back into the atmosphere from the soil aggregates. So then in terms of land management, looking at grassland management, it tends to favor good, so grazing tends to is speculated to hold more carbon than cutting or harvesting of silage, because the manure and nutrients are being recycled back onto the land by the animals. So they're less likely to be, or they're immediately recycled, so they're less likely to be lost when slurry is returned back to the soil, or if it is returned back to the same area where the silage has been cut. On lays or temporary grasslands, the ploughing of lands increases the area of soil exposed to the air or atmosphere, and that again increases the risk of carbon loss to the atmosphere. So there's many factors to consider in carbon sequestration, and obviously then as a result, the quantification of carbon sequestration is quite complicated. So there's, I suppose, three principal aspects to the quantification of sequestration. So there's the measurement, soil sampling, and flux towers, the modeling of carbon flows within the vegetation, the soil, and the atmosphere, and then the mapping of soil carbon as well. So measuring soil organic carbon is a challenging task, because it's a very slow process, and you're trying to measure it against a very large background of carbon. So in the IPCC guidelines or the National Inventory guidelines, it's usually the top 30 centimeters of carbon that is measured. And this is where the majority of carbon within the soil is. And this is the most also labile or active carbon pool, as I mentioned earlier on. Then there's the carbon further down in the soil profile. So this is more stable carbon that is held in the soil for long periods of time. There's less carbon further down in the profile that is thought. It's referred to as recalcitrant carbon or passive carbon, and detecting changes in this pool of carbon requires a large amount of sampling over long periods of time. And I suppose this is challenging maybe to do in practical terms, because you need to, I suppose, go further deeper into the soil with equipment that is more expensive than simple augering or soil sampling. So it's a challenge to measure. And there's, I suppose, a debate as to how deep down the soil needs to be sampled to capture an accurate measure of the overall soil profile. So from 50 centimeters to 1 meter is kind of where the area is recommended between that area. So instead of measuring carbon, or another method to measure carbon is to measure carbon fluxes using flux towers. So these are not a replacement for soil sampling. They're just, I suppose, an addition or a quicker way of monitoring daily or changes in carbon over a long period of time. So soil carbon samples are really the gold standard for measuring carbon, and the carbon fluxes and the measurement output from it are validated against those soil carbon samples. So this is just a picture of one of the flux towers. I think it's either in Johnstone Castle or Solihull, and it measures the net exchange of carbon daily and annually. So the tower measures the carbon flux on a daily basis. As I said, it measures it very often, 10 times per second, every second of the day. So they're expensive equipment and measure a massive amount of data. Wind speed and carbon dioxide mixing ratios are kind of the main measures that are used to work out the carbon dioxide exchange. And the difference between the carbon that is taken up and the carbon that is released is worked out from these measures. So the frequent measurement of the carbon gases in a grassland by these towers is useful to detect the impact of weather, climate, or management on carbon. So this is a chart from the work of Gary Lanigan showing the impact that a dry summer had on the levels of carbon or the rates of carbon in the ecosystem. So in very dry summers, the level of carbon losses or respiration is much higher. The towers are also good as well to give an indirect estimate of how much vegetation is grown in the field or in the ecosystem, and maybe can be kind of used as a way of measuring the amount of grass that is utilized on a research trial or in a research setting. So this chart gives an illustration of what you get out from an eddy covariance flux tower. So it shows the daily carbon flux rate, whether it's positive or negative, and the cumulative amount of carbon that exchanges in the between the atmosphere and the land and the soil. So the blue line is photosynthesis, which is a carbon uptake. The red line is respiration, which is carbon loss, and the difference between the two is the carbon exchange, as it's referred to. So I suppose it's important to point out for this measure that it's not the carbon exchange that is carbon sequestration. It's actually the carbon storage is the more important measure. So for carbon sequestration. So the carbon exchange that is measured by the equipment has to be adjusted for the carbon inputs like fertilizers, removals of forage, and other outputs, and the losses as well, to get the net carbon storage or sequestration figure. So this chart here, again from Gary's work and Gary's team's work, shows the exchange of carbon in a grassland site in Johnstone Castle over a 6-year period. So the net carbon exchange is much higher than the net carbon storage, obviously. So carbon exchange range from 15 to less than 5 tons of carbon dioxide equivalents per hectare per year, whereas the net carbon storage was usually less than 2 carbon dioxide equivalents per hectare per year. And this was in tons, metric tons. So obviously it's not possible, I suppose, to measure every site and every field. So modeling is an important part of quantifying carbon sequestration at a higher level. So at the farm or regional scale or beyond. So the mathematical models that are used are developed from the flux towers and soil carbon measurements, and they're parameterized and calibrated using this information. So some of the most widely used models are the Daisen model, the PASSIM model in France. Daisen is originally developed in America, ECOS developed in Ireland, and the ROT-C is originally developed in the UK. I think the ECOS might have been developed with European researchers as well. And these models are valid, have produced valid estimates of soil carbon when they were compared against flux tower measurements and soil carbon. So they're relatively accurate at predicting soil carbon beyond the site or field scale. One aspect of these models is that they struggle to predict grass growth well, which is a problem in getting, I suppose, getting good resolution in the daily changes in carbon. But at a higher level, they're reasonably good at predicting soil carbon. We're kind of looking at the moment at trying to adapt these models to make them more specific to Irish circumstances and over a greater number of soil types and land uses and grassland systems. So the models, some of the applications to date have shown that good farming practices have a positive impact on carbon sequestration. So we've simulated that improvements in soil fertility, soil nutrient status, and pH levels can increase or add carbon to the soil. And similarly, spreading or adding organic manures to soil has a favorable impact on soil carbon as well. Even current levels of grassland management tend to show an improvement in soil carbon, and I'll mention that a bit later on towards the end. And just the final then is that the models are also used to project the impact of climate change on soil carbon. So this graph here is a bit hard to read, but it shows the impact of different temperature increases on the levels of soil carbon. So at higher temperature increases, the amount of carbon in the soil stored in the soil is less. So just to, I suppose, reconcile then carbon sequestration with the bigger picture of agricultural greenhouse gases on Irish farms. So as we know, the bovine herd is the principal driver of agricultural emissions. And as we've heard in earlier talks by James Humphreys and Joe Patton and more, that I suppose Irish dairy systems and beef systems are amongst the most carbon or greenhouse gas efficient production systems in Europe and in the world. Improving the efficiency or productivity of these production systems further will be difficult, but there is, as earlier talks have outlined, there is ways of doing this, and the Teagasc MAC or marginal abatement cost curve also outlines in more detail the actions that can be put in place to drive down our greenhouse gas emissions per unit of output. But to, I suppose, achieve or to move towards climate neutrality, we'll need to enhance the level of carbon storage on our farms to balance the greenhouse gas emissions. So this slide is shows in the graph here that a typical dairy producer emits about 9 tons of carbon dioxide equivalent per hectare, and for a beef producer it's less than half of this. So the main greenhouse gas emissions that are emitted are methane, which accounts for about 55% to 65% of the greenhouse budget of a bovine beef or dairy production system. So it's the largest contributor. Nitrous oxide then from fertilizer, from grazing cattle and spreading of manure is generally the second largest source of greenhouse gas on a farm, and carbon dioxide then, unlike most sectors, is actually the lowest contributor on a beef or dairy farm. However, carbon losses associated with the production of concentrated feeds brought into the system can have a significant impact on the greenhouse gas budget in some cases. And these effects or these emissions were quantified using a life cycle assessment approach. So looking at an average beef production system in Ireland and looking at the greenhouse gas emissions or the greenhouse gas emission efficiency in terms of live weight gain, the National Farm Survey shows that it's around 12 kilos of carbon dioxide that is emitted per unit of weight gain. And generally, as the stocking rate increases and the efficiency improves, the greenhouse gas emission efficiency or the gross greenhouse gas emission efficiency of the production system increases. And for lower stock systems that are less efficient with less less output and less grass utilization, the greenhouse gas emission efficiency tends to be lower, so they have a higher emissions per unit of weight gain. Then when we look at it in terms of carbon sequestration, so we look at the carbon that is sequestered per unit of weight gain, we can see that the rates of carbon sequestration may be actually higher on the more extensive or lowly stock systems. However, it's important to say that the rate of carbon sequestration is likely to be overestimated or mightn't be correctly estimated on these systems, as I suppose our level of knowledge around the rates of carbon of the effective stocking rate on the measure are not very sensitive. So the rate of carbon sequestration on the most intensive or the most efficient systems in terms of grass utilization and production don't differ to ones that have lower levels of utilization and lower stocking rates. So when we look at the net or the gross net greenhouse gas emission, then the inclusion of carbon sequestration reduces the greenhouse gas emissions across all beef systems. It's likely that the effect may be larger on more extensive beef farms, but it needs more research. It's also possible that some of these beef systems could be already climate neutral and that they are maybe managing their grassland very well already and sequestering large amounts or just that level or more of carbon, which is offsetting their greenhouse balance. So then finally, the amount of carbon sequestered on beef and dairy farms could be enhanced by better farm management or good farming practices. So a typical beef farm emits about 4 tons of carbon dioxide equivalent per hectare, as I mentioned earlier. On average, carbon sequestration by grassland and hedges or hedgerows offsets these emissions by around 45%. But the rate varies from field to field, farm to farm, and from year to year. So as you can see, I have in brackets underneath the variation or standard deviation around these figures. So you can see that in some cases it might be close to 0 in some years and much higher in other years or in different farms. So the gross net then is the emission left over after the carbon sequestration is accounted for. So in this hypothetical example, if we were to plant an additional hectare or quarter of a hectare, with a mixture of conifers and broadleaves, this would enhance the carbon sequestration by about 2.3 tons of carbon dioxide equivalent per hectare, which would probably be sufficient or enough to make a beef farm, in this case, or the average beef producer, net greenhouse gas emission zero or close to zero, or in other words, the farm would be climate neutral if they made this change. Alternatively, better or changes in farming practices that add this level of carbon would be another way around achieving climate neutrality for a beef farm. Then obviously for a dairy farm, the rate of afforestation or planting required to bring a dairy farm towards climate neutrality is much higher than a beef system. So you'd require 2/3 of a hectare or more than double the amount of a beef farm to offset the level of emissions. So to summarize, I suppose it's clear that carbon sequestration has an important role to play in contributing towards delivering climate neutral livestock production systems, so reduces greenhouse gas emissions in grass-based livestock systems. I suppose there is still a job of work to be done in quantifying the amount of greenhouse gases that are actually reduced by sequestration, as the rate of the process is variable and it's uncertain. So we need to measure, I suppose, more sites and a larger range of sites, more representative of the regional or national picture, to get a better handle on exactly what carbon sequestration is contributing. The final slides there I show in the farm level research shows clearly, I guess, that the distance to climate neutrality targets are, as you'd expect, lower on more extensive grass-based livestock production systems, so beef, sheep, or dairy. Achieving or moving towards climate neutrality on high output, efficient, productive grass-based beef and dairy systems will be more challenging. There is a number of good farming practices that can be implemented to get gains in carbon. Soil fertility, introducing I suppose some deeper rooting species into sward might be an option in some cases, or ways of increasing carbon in the soil or organic matter levels. And I think, I suppose, rotational grazing and I suppose better grassland management and grass budgeting will help in this regard as well, but more research is required to quantify the levels of carbon that will be stored. And finally, then, there's, I suppose, a lot of work or a lot of interest in this area. The Nefertiti project is one example of a research or a demonstration network that is aiming to transfer these practices into practice on commercial or real farm settings, to see what is feasible to do on farms and what level of carbon sequestration is likely to occur on these systems. And looking at the long-term targets, then I guess it's likely that afforestation and low emission technologies will be needed to achieve these targets. And I guess that these have been covered by Gary and others in previous talks and will be discussed in future talks again, I'm sure. So some helpful links that might be useful on the different projects and strategies are available from these links. So that's it, Pat. Thanks for.
Okay, if you could just stop sharing there. Thanks very much, Donal. A lot of information on a complex topic. We remind you to get your questions in using the Q&A. We have a number of questions in already. Pádraig, do you want to just introduce a few of them?
Yeah, thanks very much, Pat, and well done, Donal. Great presentation. One quick question here, just when we're after going over the slide in relation to the 1/4 of a hectare of forestry required on a beef farm and the 2/3 of a hectare required on a dairy farm. The question is, what is your average beef or what's your average dairy farm? If you wouldn't mind just outlining that, Donal, please.
So yeah, no, it's a good question, and I should have probably explained it in more detail. So in these examples are average in beef and dairy systems, where for beef an average suckler calf to beef system taken from the representative surveys from the National Farm Survey. So the stocking rates, the level of production are all consistent with the Teagasc roadmaps and the CSO statistics. And then on the dairy farm, again, from the National Farm Survey, we took the information from those statistics, and they're explained in a lot of detail in the sustainability reports that Cathal, Buckley and others would put together recently.
Okay, Donal, another question just around the increased sequestration. You know, you mentioned forestry. Obviously, if there's farmers out there that want to do their part, and you mentioned good agricultural practices, what other options are there for farmers other than going and planting the ground?
So yeah, other than planting, I suppose there's a number of different options. So we're talking about, I suppose the first thing is soil testing and implementing, I suppose, a nutrient management plan is kind of the first step on any farms that aren't doing that already, to kind of get a better balance between carbon and nitrogen inputs. Liming, as I said, was another one to maybe improve the pH levels or reduce the alkalinity of the soil, but it's usually the acidity is more of a problem. Then for farms that maybe have lays or temporary grasslands, if they could maybe increase the period of time that the land is under grassland, or make sure the land is covered with some vegetation so it's not exposed, is another way of keeping organic matter in the soil. And then I suppose I mentioned ploughing briefly, maybe trying to minimize the use of the plough and min-till are kind of the options I think that can have biggest impacts on conventional farm or on farms on mineral soils.
Okay, thanks very much, folks. Lots of questions coming in. There's one here, Donal, just extensive high nature value pasture systems cover over 30% of our agricultural base. Carbon sequestration sampling on these areas show they have highest stores of carbon. The value of extensive systems needs to be emphasized, more place benefits for water and biodiversity. What plans are there in place to carry out more work on this substantial part of our land basis in terms of greenhouse gas balances and advice for management?
Okay, so I think there is a lot of work already being done in this respect through the Natura schemes, I think, and even the LIFE projects and the Burn Life are some good examples that are trying to, I suppose, that are maintaining good levels of biodiversity in those systems. And I think as part of the Signpost farms, there is a plan to put in place measurement of carbon across a range of different types of farming systems. So maybe these systems or ways of farming could be included, or there could be a collaboration with other projects like the LIFE projects or Natura projects to look at I suppose, the greenhouse gas balance and carbon sequestration levels on these more extensive systems.
We have another one here. If you were to increase your organic matter in your soil by 1%, is there any estimate, Donal, on how many tons of carbon you're sequestering? Or any similar kind of benchmarks that people can use themselves?
Yeah, so I think that's like, I don't think I'd have to take, I wouldn't have an accurate figure off the top of my head right now, but I know in France and Ireland, I think, is contributing towards it as well. They have the 4 per 1,000 initiative, which is trying to increase the level of carbon in the soil by 0.4%. So 1% is probably a large, very large increase. So 0.4%, they were estimating was the equivalent across all of the soils at the global scale of the emissions that the world emits for 1 year. So I couldn't tell you those figures off the top of my head now, but a 1% increase in soil organic matter sounds like it would be a large increase.
Okay, we were putting you on the spot there, so fair play. It was a good stab at it. Donal, sown clover and multi-species swards is something that's come up a couple of times in questions here, and it says that it could increase carbon sequestration. Is there anything to show that volume of sequestration could be better or greater than afforestation? Are you familiar with any research in that area?
So I know I only gave a few examples there of the levels of carbon added by good management practices, like, as I said there a few times, better soil fertility. I expect, I suppose, deeper rooting species and multi-species swards would have higher levels of carbon sequestration or additions, but I think compared to forestry, where they're talking about levels of 10 tons of carbon dioxide equivalent per hectare, or 3 or 4 tons per hectare, I don't think they will be near those levels. I could hazard a guess it's less than half or something, but I'd have to look into that in more detail.
Okay, that's an indication. Just going back to just a little bit of a clarification on the quarter of a hectare for beef, and 3/4, or sorry, I think it was 2/3, not 3/4, 2/3 of a hectare for dairy. There's a question here just on the rate of afforestation. If we stick with the beef example, so if you have a 40-hectare farm, are you saying that we need to plant 10 hectares of that farm, or for a 40-hectare dairy farm, you need to plant 2/3 of that farm?
Yeah, so I probably should have I tried to mention that this is like additional. So this is this is a costly way of going about it, afforestation. So this would be additional land on top of your 40 hectares. So you'd require another 10 hectares or to offset the emission from that system. So for 1 hectare of beef land, you'd need 1/4 hectare of forestry, so 1 1/4 hectares altogether. So
if you have 100 hectares, you're planting 25 hectares.
You need to get 25 hectares from somewhere, yeah.
Okay. Kind of more policy related question. What do you think of the note in the Farm to Fork stating robust certification rules for carbon removals in agriculture and forestry are the first step to enable payments to farmers and foresters for the carbon sequestration that they provide?
Yes, so I guess obviously when it comes to payments and the Common Agricultural Policy or carbon markets, then obviously there will be a requirement that these improvements in carbon levels in the soil would have to be verified, checked, and robust. So I think this will be a very important part of any schemes going forward in this respect. That there would have to be some level of soil monitoring, measurement, well, not measuring, but more sampling and checking the change intermittently over time in the levels of soil organic matter or soil organic matter in the soil. And I guess there's a question then around how deep do the soil samples need to be, and what are we going to have to sample to verify what is actually happening at the different levels in the soil.
And are you aware of any work being done, Donald, to, I suppose, quantify from a farm level or from a farm financial level what is required to be returned to the farmer to attain that extra 25% of beef land, or that extra 2/3 of dairy ground to put it into forestry, or to put in some of those good agricultural practices that you've outlined?
So sorry, Patrick, I missed.
So where's the incentive going to come from for the farmers? You know, like if Farm to Fork, if we're saying that farmers are going to be rewarded for doing this work, has there been any quantification of the money required?
So I think really we're just from my understanding, and maybe Gary Lanigan might have a better handle on this, but I think we're really just trying to get our better understanding of what's actually happening in the soil and levels of carbon storage and sequestration within the work that we have been doing. So I guess it's probably hard to put, payments or financial figures around that when we don't have a solid, I suppose, footing in regard to the amount of carbon that these practices are adding to the soil, which is, I suppose, a major challenge in itself.
And how far away are we from that, Donald, in terms of quantifying that? So future work that's within, I guess, your pipeline and the pipeline of work, the research that Gary has ongoing?
Yeah, I know that there is, there is through the catchments program, through the Signpost Farm initiative, our program, a plan to really increase the amount of carbon monitoring on a larger number of sites across the country. And I think it's looking at like a 5-year time horizon to see what happens on those sites. I suppose to measure more sensitive to the different soil types, and then from that, I suppose, to be able to make payments that reflect the level of carbon that's being sequestered by these soils. Like, this is just my own thoughts. I'm not sure exactly how that would work, but that's probably a way it could go.
Okay, another question here. If a national soil sampling program was considered, is this sufficient to establish a baseline for carbon? And how often would it need to be repeated?
Yeah, no, that's another very good question. I think, and if there was a soil sampling program put in place that could, at a national level, it would be, I'd say, a very strong way of verifying what's happening on the ground. I think it's what the EPA or what the inventories is their kind of absolute measure, is what is actually happening in the levels of organic matter in those soils, and measuring, I suppose, the bulk density of those soils is a different angle or a different aspect to be considered as well. But yeah, putting in a program like that would be, a very clear way and send a strong signal that we are actually very robustly measuring the levels of carbon in our soils and the change over time. And I suppose maybe through the advisory programs then, through, I suppose, the information and the knowledge that's being transferred, we should see over time, hopefully, an improvement in the levels of carbon in the soil, and that would, I suppose, then be transferred into inventory. And I'd say that's probably the way it would have to go to get verification accepted.
And is it possible to have it transferred into inventory like that, or does it have to go through IPCC?
Well, I suppose I speak loosely there in that I suppose EPA, inventory, IPCC are probably all in a similar loop. So if the EPA are, I suppose, implementing the inventories, they would be following the IPCC guidelines. And I think, or I know that that's kind of from the measures or from the reports and from listening to their Philip, as I suppose he was one of the first speakers on the series. They're the way that they're I suppose setting the requirements for the verification. So I think what the EPA and the inventories are doing is really the same as the IPCC.
Donald, a question there in relation to reseeding and the I suppose what happens with grassland is that when you reseed, you lose a substantial amount of carbon, and then you build it up again over a period with a grassland in place. Are there measures in relation to practices at reseeding that help to reduce those losses?
So I know from, I think, I'm not sure if James Humphreys covered it in his talk on low carbon dairy farming, but as he outlined, there was, I suppose, a large release of carbon from the soil from the initial reseeding. And I think it was through conventional reseeding, so ploughing, direct drilling. So maybe there's some, I suppose, practices around min-till or, stitching, well, maybe not stitching in, but something like that that would, have less disturbance of the soil, and even reducing the amount of time or period the soil is exposed is really critical to the levels of organic matter that are lost. And other things maybe like weather conditions, etc. Having, I suppose, what is controllable obviously is limited, but trying to do the best around those things would be ways maybe of limiting the loss, and then as a result there might be, or there should be less, the length of time for the carbon to be recovered would be less, and maybe build up slowly or gradually as well over time.
And there's a few questions in relating to drained high organic matter soils and their contribution and what can be done in that space and what work is going on in relation to that.
Oh, thanks for that. Yeah, I think that's a very important piece of work that I think the inventories and EPA are very, very anxious to do, because at the moment our grasslands, based on the current science, are considered actually a carbon source or a carbon loss, because any of the grassland that's being farmed on those wetlands is considered to be releasing large amounts of carbon. So I suppose there's a job of work to be done there in ground truthing and checking those systems to see are those drains still functional, and if the water table was restored on those farms, would it really have a major detrimental impact on food production if those systems are already probably extensively stocked anyway? So I think that would be a very important priority area to verify what's happening on that area of land, and what are kind of the practices that farmers could do that would, I suppose, minimize the carbon loss from those types of peaty or organic soils.
So I suppose just as a final point, what are the key areas of research that you and your colleagues are involved in now? I know you've outlined a good number of them in bits and pieces, but what are the key areas of research? And I suppose you might give us an idea of the extent of the research required for us to, I suppose, improve our sequestration, verify our sequestration, and deal with issues like plugging the losses in some of those landscapes you're talking about.
So the key areas that we'll be working on, I suppose, in the immediate future are through the European Joint Programme on Soils, which is, I suppose, putting in 80 million across the EU to look at soil health and soil carbon. I suppose plugging the hotspots is a good way to describe what needs to be done on the heavy or the organic soils, and that's an area of work that we're, I suppose, we'll be engaged with more with the department to verify what's happening on those soils. And then I suppose finally, in my own work, which is largely around modelling and simulation, I suppose to get a better understanding or models that are more sensitive to the changes that are happening. Obviously, I showed stocking right there, and it was probably a little bit misleading in the figures, but it just shows, I guess, kind of where we are at. And you would see similar things in France and other countries. So getting, I suppose, more sensitive models is also probably another priority area as well.
And in terms of any possibility of payment of farmers for carbon sequestration, this work is absolutely critical.
Yes, I think so. Yeah, for the verification and reporting, we have to do this type of work. Otherwise, I just don't think it will be approved, or it won't go anywhere, I don't think.
Okay, well, listen, thank you very much. I think we have to end it there. I think we could keep going for quite a while. Obviously, a key area of research in the future. Thank you for sharing that with us, Donald. Thanks, Padraig, for your help. Just to remind you that next week we're, I suppose, changing back to water issue again, where we will have Ken Buck from the Department of Agriculture talking about the Woodlands for Water and the Woodlands for Water scheme that's in place. So until then, thank you from ourselves and our co-hosts, and look forward to seeing you again next week. Thank you. Goodbye.
Cheers. Thanks.
All right.